Hey, my name is Sascha-Oliver and today I'm going to demo functional validation in PHP. And before we do that, I want to show you maybe more or less so people are on the same page what such validation could look like in Laminas. So for example, they use this example here. We have a new emails, new input, we get a validator chain and attach an email address validator. Then we can go on and create a password input, attach a validator string length 8, so should probably mean like 8 characters minimum. Then we create an input filter, we add the email address, we add the password, we set the data, and then we can say if input filter is valid, the form is valid. Else the form is not valid, for each input filter, get invalid input as error, print error, error, get messages. Okay, so this is like more or less an object-oriented approach. Lots of code to write and you need to understand the library that you're using. So maybe you're not familiar with Laminas but you're using some other component from some other framework, then that's fine. But the fact doesn't change that much. They all look like more or less the same, right? So another possibility to remove some classes would be like we use the factory and work with configurations here. Makes it a little bit more easier to read, and so that's much better in my opinion than creating lots of these manual classes. And yeah, the other possibility that they also introduce is like, well, we can create a new class named input filter. We can create a new email input filter, and then for a person, we create an input filter and merge email input filter and merge the name input filter. So yeah, Laminas is showing us like 3 different ways of how you can do input filters. One by classes, so you can extend for each field, one by configuration, and the other you use defaults, and that's here, you use defaults and attach stuff that you need on the fly. And once you have this input is validated, that's fine, and then you want to turn it into an object. So there's another component, Laminas hydrator. So for example, you have an array serializable hydrator, there's some data, and then you get some object once you hydrated this. There are different things here, object property hydrator, reflection hydrator, and so on and so on. So basic thing in an object-oriented library is you have some kind of huge amount of classes that you want to work with, and let's check here Laminas input filter. I don't know how to write this. Okay, here we go. So you see for yourself, this is the Laminas input filter repository. So let's have a look at the input filter class. They extend the base input filter. That's a little bit of code, not too much, but let's check the base input filter again. And then you see, oh, that's a lot of stuff to understand and to go through, and so you have to learn your libraries, right? The base input filters is 600 lines of code, so that's only one class, and then you have all these other classes. So I want to do the same, but with pure functions and no library at all today, okay? And we also include the hydrators part, which is another huge stack of classes and objects that you have to learn and live with. But again, as I said, today I want to try to make it purely functional and without any tools. So I show you what I have right now, and then we go through the steps, okay? I have here an address. An address consists of street 2, city, zip code, and these are all types. So we have a constructor, we put these things inside, and we have some getters for them. For the city itself, it's basically a wrapper around string. Same for other things like first name, last name. And then we have a contact which has here first name, last name, email, phone number, and an address. So with the address we have one nested level. The address has this, the address has these fields here, but the person or the contact is fairly flat, but this has only one level down for the address. And here you have phone numbers, all just wrappers around strings. So fair enough, okay? These are the things that we want to work with. So these are our domain objects. And before we go further on what we want to do here, is I want to establish a few basic things so everybody's on the same page. I'm not going to use any bad words here today like functor, applicative, or monad, and we are not using any functional library for PHP that would help us for the task. We are doing everything pure and from scratch and without any additional tools. We're just using Composer here. PHP 7.4's requirement, and we still use Laminas, Validator, and I18N. Internationalization, this is used for email address and phone number validation. I just reused this part so I can check if it's a valid phone number or valid email address. I don't want to make like right here huge regex, so we just reuse this for now, but you can replace it later, of course. The goal here is to show this thing and not to work on a perfect email validator or phone number validator. Okay, so we have a function, and function expects a value, and we use another value and bring it into scope, and then we return a plus b. So instead of writing this, I prefer to use this style, the short arrow function from PHP. So you should be familiar with this here, that this is equivalent, okay? Next thing, so again, I'm just starting from scratch. We're building something up here, and then you'll see where we're going with this, okay? So that's a new address, and the address starts with a street, and then we have street 2, and then we have a city and zip code, okay? So zip code, city is New York, street, I don't know, that's the main street 1. Okay, so we can build an address like this, and we can say raw dump address. That's our intro file. So we have our address object here, so everything as expected. So a next trick I want to show you is how we can do something similar, okay? Say we have data, okay? And now I can say address / new address data. And we extract this again, okay? So we can get rid of this. And as you see, it works. But let me change the order. So zip code first, then city. And you see, we have type error. So we can use array unpacking here to build the constructor. So that's another trick that we are using. And the third one, it's only one more, and the rest is, then we go to the functional validation part, is I use this a lot. So switch true, case A, instance of foo, then I return a foo value, I don't know. But there's the other instance of this is a bar, then I can return a bar val, okay? So this is cumbersome to write, so I don't like this. Let's do something like match type A, and then I say foo class, and that's a function I want to execute, and this is a foo val. And if it's a bar class. Then I want to execute this function that does a bar_val. So this is what I want to do. I want to have this function match type. Okay, that's it. That's not much to ask. So I'm going to show you the implementation of the match type function in a second, but that's not really important now for this video. But I just explain you, like, if you see match type this, it's a shorter syntax for this here. Okay. So next thing, if we want to validate something, so we have a value a, which is a string, but looks like an integer, but really it's a string. So we want to ask, we have a function that checks this value, and well, what does it return? If isInt a, we can say, well, it returns true, or let's say here function test. Okay, and when it's not int, then we can say, well, we return false. But then we have no error message, so let's say we return not an int. Not really that nice, but it's kind of working in the right direction, right? So what we have in Haskell, we call this a sum type. So let me write you some real Haskell code here. So either we have left A or right B. That's a sum type in Haskell. And we can basically do something similar in PHP, just with classes and stuff like this. We don't have like these super nice syntax that they do. But we can say, well, the validation is a function that returns a result. The result can either be error, and in error case I see an error in a list of messages, or the result can be a pass. So we are good. And in case we are good, I want to pass whatever we tested. Okay. So we test A, we get an error with some messages, we get test A, and we have a pass. So that's at least the goal. So the result, so both of them have a value there, right? So the error and the pass, they have here a list of messages, and here's just A, we don't know what it is inside. You can have like annotations and some for static code analysis, but that's another topic. Okay, so our validation result. We have here a private value and a final public function construct. We check if this is not an error, not a pass, then you extended this and you're a bad person, okay? We store the value, we can grab the value. Next thing that we want to do is, I have two more functions I want to add here, map and bind. So I go through this real quick. The error case extends the result, and in case we want to map an error, we just return the error, and if in case we want to bind the error, we just return the error. So for the error case, these functions are fairly simple. In case we encounter an error, we stop the process. We don't do anything further, we just pass the error along. So that's this part here. In case we have a result, it's a little bit different, a pass. So if we want to map a function, we return a new pass with the value that we have here applied to that function. Okay, so we give a value, a function from A to B, basically. So a function that does something with the internal value of this pass object and maps it to some new pass object. And we have bind, which also returns a new validation result, but the function does it itself. So we don't wrap it here in the path, the function does it. So whatever we map is always a path again. Whatever we bind may be an error, okay? But the function has to do this, and that's all. So let's go core. So as you've seen, that's here we want to code. I have some imports already, so that we want to use later. We can make this small. So for every function, we have a const additionally. Maybe that's something I should have done before. So there's one more trick I need to show you, okay? Okay, how do we get this? We have a function that expects a string A and a callable B or F, okay? So what you want to do is return F from A function. Okay, that's another test function. So we want to test that the test string string to lower. Okay, so if we have this, that's good. We can do a string to upper. String to upper. F, return F from A. Echo test, string to upper. Okay. So you see it makes it all cap, or we can go arc first. Yeah. So only the first character. But this is a string here. This is the thing that we don't like. So what we do here instead, we say it's a const arc first, and this is called arc first. And now I can do this. See, it works. So for every function I create this constant as well with the name, same name as the function plus the namespace if I have one. Okay, so that's the fourth thing I forgot. So for functions, for functional programming, the building blocks are functions, not new operators, for example. So we don't want to have like new error somewhere, we call a function. And we don't want to have new path somewhere, we call this function instead. Fairly simple. Here's our match type function that you've seen before. So this is how it's get implemented, not really important right now. Yeah, you loop through the patterns. If the object is an instance of the given type, the key in the patterns array, then we return the function. Otherwise we have a default value you can execute, or we say, well, this pattern is not exhaustive. And last thing we have a tail. So you have an array and you want to have the tail of the array. So in functional programming we say like lists have a head and a tail. So the head of a list is basically the first element. So we could say head is equals to list 0, or it could be null when this list is empty. So in this case we don't have a head. But array shift even works on empty arrays, so we can always get a tail of an array. So that's array shift. We push away the first element and that's it. So these are the base functions that we need. This is everything we want to have to start. And so let's start with something simple, okay? We want to do, let's check if something is in a string, okay? So what we want to do is I have a function is string, and I have of course the constant again with the same name. Function is string, and I give it an array of data and a string field. So you want to check if this field is in this data array, so we have this, and this whole thing returns a result, right? So how does it work? We can say that when this thing is a string, when is string data field, when it's not exists, we give a fallback null, so it's not a string, right? When this is a string, we return pass data field. Easy as that. Oops. And otherwise we can say, oops, we fail, and the error message is field is not a string. Pass. Error. We called it error, not fail. Okay. We're good. So we have an isString validator, and we can return a pass or an error. So let's check this really quick. I think I have here my sample file, some imports on top already, so we don't need those. I have here a data, street, city, zip code, first name, email, phone number, everything we've seen before as domain objects. And let's do var dump isString data. Is it a string, the street field, right? Let's see. So we have a pass, and the value is main street 1. Perfect. So let's check for street 2. Okay, let's check for street 3. And we see it's an error. Street 3 is not a string. So we have already very basic validation with this. Okay, what next? Non-empty string. Non-empty string. So we give a function non-empty string array data and a string field, and we return a result again. So how do we want to do this? Well, we can say it definitely has to be a string, right? So we can call this. But what else? We need to know, like, it's not empty. So what can we do? If you remember, we have this function bind, which lets us execute a callback that returns a new result. So let's use this, and as argument we get some value, which is the string in case we have a string. When it's an error, the error doesn't bind, it just passes the error along. Remember? Show you. Bind from error returns the error. Okay, so we're doing nothing when this is an error. So then I can check, is this empty, this value? In this case I can say, well, this field is expected a non-empty string. And otherwise I can say it's, error, that's the pass constructor, and I can say, well, I passed the value. Oh, sorry. So that's a non-empty string implementation. What else can we do? Let's say phone number. We have the phone number validator, so const valid phone number, function valid phone number, array data, string field, and we return as a result. So phone number. Phone number is a non-empty string, right? So when it's empty, then it's not a phone number. And once we have the phone number, let's say we have a new phone number validator. Okay, I need this here real quick. I just don't want to work with regex here. This is from Laminas. So the phone number validator, we bind this on, let's go new line, a function which gets the phone number as string, and then we say validator is valid this string. So when this is valid, right, then I can return a pass of this value, and otherwise I can say, well, this is an error, and I can ask the validator for validator get messages. Okay, and once I have this, I have again this function, and now I don't want to bind it, I want to map it. Okay, and this goes like this. We return a new phone number, boom, put the value in here. So we have the hydration resolved. The only thing that we don't like this much is about the validation error messages, and there's a small trick that we have to do. Validation error or validator error messages. Then we have a string field and an array of messages. They come from the validation class that we are using here, and we array map those messages. Okay, we have a function string message, and we say this is a field message, and this is array values messages. So we need to use this here, I'm sorry. You'll see later that this will give really ugly error messages otherwise. Okay, I can move my camera here a little bit down so you can read this. Okay, valid phone number, we grab the phone number validator, we say it's a non-empty string, we bind, check if the validator is valid, then we can pass, otherwise we get some error messages, and we map this to a phone number object. Okay, let's try this, right? Oops. Let's check for valid phone number, and the field is phone number. So validation non-empty string must be an instance of, okay, there somehow I messed this up. There's a return missing. Here as well. Okay. Oh, we have a valid phone number. So this number is valid. Let's call him and see if he's awake. No, just kidding. Let's put some numbers up front. So this shouldn't be a valid phone number, right? No, it's not. So that's nice. So we have the whole hydration already solved, and we can check for valid phone numbers and for not empty strings and stuff like this. So what else do we want? Once we have the valid phone number, we can copy this and say we check for valid zip code. Okay, valid zip code goes basically the same. We don't have a zip code validator, I don't know. With non-empty string, we map it to a zip code. That's it. Okay. Now we have a zip code validator. Or let's say we can also bind it. Let's do some preg match. Okay. False. Preg match. The pattern is da 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 da. Backslash D 5. Let's use this for now. And the value, if that's the case, we have not preg match, then it's an error. The error is field not a valid zip code, or it's a pass with the value. Boom. So let's check the zip code as well. So that's a valid zip code. And here's the zip code. So it works. Okay, let's make it here a letter. That's a letter still. R. No, so it doesn't work as expected. \d5. We don't match this pattern. I don't know. Looks good to me. Pattern, subject. Subject is the value. I don't know. Let's forget about this pattern matching here, but forget about it. We map just this into a zip code, whatever we put in here. The focus is not on zip code validation here, obviously. But we have one more problem. We need to wrap these things into an address object and then to a contact object, right? We can do first name, last name, zip code, but how can we do like address? How can we put this here into an address? Okay. In order to do this, we have to do some different stuff. Okay. So first of all, if we want to parse multiple things, we have to combine them with AND. Let's try this. Okay, we have a const AND, and it doesn't work. It's a reserved keyword. Okay, let's make it double D. Okay, namespace AND, and we have a function AND. Okay, if we AND the two results together, yeah, then we want to have another result. So result A and result B gives us a new result. So, any ideas how this implementation looks like? Right, we pattern match with our match type function. We match on A. Oops. So we match on A, and then we have the possibility that this is an error. And when this is an error and we AND these things together, we have already an error, right? So what we do is we match the other one as well, okay? And the other one can also be an error. In this case we have to do something, or the other one can be a pass. So if A is an error and B is a pass, then we return A, because it's not both, obviously. And if A is an error and B is an error, then we return an error, but we have to merge the error messages, right? So we do error merge A value, B value. Like this. The other possibility is we have a pass here, and in this case we match the type for the other one as well. And let's check. If we have a pass on A and we have an error on B, then we return B, right? It's an error. Let's have a pass here. So A is a pass and B is a pass. then we have a pass, and what's the result? A is a result and B has a result, so we can't really put those together. So what we're gonna do is we add another callback here, callable f. And f is a function from a to b to c. So we execute f here with a comma b. And that's it. Oh, a value, b value, of course. Right? So, again, if a is an error and b is an error, here, both, we have two errors, we merge the results. A is an error and b is a pass, we return a, this error. If a is a pass and b is an error, we return b, the error. And if both are pass, we create a new pass with a and b combined with the function that we provided. Okay? So far so good. Next thing, we have more than two. So we can have and 3, and we have a result type C, and we implement this. Then we have for 3 things, and we go for and 4, and so on, and then we have for 4 things. And this is something that you see fairly common in lots of functional libraries, that these kinds of functions are repetitive. But we don't want to do this today. We have a const all, so we want to check all of them at once, okay? And we don't want to do this crap with having this function 25 times for 2 until 26 arguments, and then hopefully nobody has ever created something with more than that. So we go to all. In case we have all, we also need this callback, right? And if we want to check for all, we have to at least check for one result, okay? And other than the first result, they may or may not be more than the other ones, okay? And this the whole thing returns a new result object. So what can we say here? This is the first time we use switch again, because we're not switching on true. We're switching on count how many other we have, okay? Let's say we have 0 other arguments. We have just a function and one result, okay? So in this case, we return the result and map the function here. That's it. In case we have 1, we can AND those together. So AND, yeah, I don't know yet what this function is. Some func, and E and ES, the first one, and then we map the function here. But what do we here? So here comes my idea. Again, I'm not a professional functional programmer. I'm just learning, and so maybe other people have better ideas, and maybe they do, but this trick works for me, okay? So when this is an array A, then we put B into this array and we return A, and otherwise we return an array of A and B. So what we want to do is just collect these things together. So now I can use the constant that we just created. Nice. So we have the case for 1 and we have the case for 2. So what if we have more than that? Well, then we can call this function recursively, right? And we AND these together. Oops. We AND the collect with E and the first one. Okay. And then once we have this, this is the first. This one. Once I AND these things together, here I have the E's. And the E's is the tail of the E's. And you remember we have this tails function. And why is AND? Okay. So let's check this again. We have all. If we have just one, this one is not present, okay? We have just this one. We map the function on it. If we have one more here, we AND those together and map the function afterwards. Or we have more than this, and then we AND the first and the second together, because we have at least two, right? And we put the tail again here, and we do this recursively. So, can we use this? Let's try. So, we want to check that all is true. So, the callable, let's leave it like this for now, okay? And the first thing, well, we can reuse this here, who cares? And then we say validation non-empty string data, and this is for street. Sorry. Let's try. Function name must be a string, validation core 36. So somehow I messed this up. Function name, so it's coming from a match function. 139. 113. Here. And this pass I damaged. Okay. So we have a pass and an array because we collected this. Remember? Main street, zip code. So we can check for multiple things here, but 2 is only ANDed. 3 is really recursive, right? So you see it works. But what happens if we don't have a street? Street is not a string. What happens if I don't have a city, nor first name, nor street? We get this amount of messages back. Okay, so that's so far so good. Anything else that is missing? Let me check. We want to have the building of the address, and the street is optional. So we have one more thing for optionals, and optionals are very easy to implement actually, and we can do this. Okay, so const optional namespace optional. Okay, so and we have a function optional which expects an array data, string field, and a callable f, and this returns the result. Okay, so optional return null is equals data field. If that's the case, then we're good. So that's a pass, null. And otherwise, we call f on data field. Okay? So now we have this optional. Let's fix this here real quick from before. First name, last name, zip code, valid zip code. Oh, okay. Okay, so we go validation, optional. Optional is data street 2, and this is an optional string. Okay, so we can also map this value to new street 2 string value. Oh. Okay. So like this, we have a street. Street we can map as well. New street. City. Let's map this also real quick. City, and we map the first name and is already a zip code, right? Okay, so we have here all our results. And we have this here, this nice thing. Okay, so address is equals to all. Let's copy this here real quick. And we get the street. Then we get street 2, which is optional. Then we have the city. And we have the zip code. And this is var_dump address. And then we have contact, which is also a validation. fnv to v, and then we go first name, last name, first name, last name, or what else do we have? Email, phone number, address. Okay, email, phone number. I think we have valid phone number, and I don't need to map this here. And here we have valid email. We don't have valid email. Okay, let's do this really quick. Another quick exercise. Okay, const valid email, namespace valid email, function valid email, array data, string field, and we return a result. Validator is new email address. So return non-empty string data field, bind validator is valid v equals. If that's the case, then we return pass new email address v, and otherwise we return error and validator messages field validator get messages. This goes here. Okay, let's do this here, multiple lines. Bind fn is valid, pass error. This is from bind. This is from bind. Okay. So a little bit formatting, so it's easier to read. We check, get the email address validator, check if it's a non-empty string. We bind when the validator is valid, pass new email address. Email, sorry. Otherwise, validator error messages for this field. Okay. Valid email, data field, boom. And here we have address, right? So let's check this one first, the address. Sorry, new address. That's our trick, right? We see it works. And contact, new contact. And let's disable this. Rather contact. Oop. And you see, validation pass, contact, first name, last name. Let's damage this again. Some access. Oh, this is not valid. Email address is not valid. Street, we make it a. Let's damage more. See what we can do? Expected non-empty string. So we can do all the validations here and we can pattern match. Var dump, match type, contact, error class, fn, some error, pass, class, all good. So match type contact. Oh. All good. Okay, this is the var dump here that I wasn't aware of, I didn't delete, so that's all good. See? We remove this. Pattern is not exhaustive. I don't know why. So there's another problem. This is a validation error. Problem in the pattern matching. Okay. So that's basically it. All I wanted to show. There's more stuff you can do. Of course, you can at next implement OR for OR Boolean. Maybe that's something, I don't know, 5 minutes more. I'll show you how to implement OR and Booleanish parsers, okay? Very, very cool. Very cool thing, very easy to do. The only thing for OR we need is pattern matching again, and we have our match type function that removes a little bit of the boilerplate. Okay, so const or, so we have, it's a reserved keyword. Okay, so let's do it with double R instead of R. Function R array data. No, this is not an array data. We are two results together, right? A or B, and in case error message, in case we don't have one of those, we can overwrite the error message. Okay, either this or that, and if both not, we provide the error. Okay, so match type A. So A can be error class, match type of B, and B can be an error, and if B is an error and A is an error, we return error mid with the error message here, and in case we have a pass, we can return just B, and in case we have a pass here, then we can simply return A. Okay, that's our OR implementation, and now we want to parse some Boolean stuff. Okay, and check if it's bool. So there are two things I want to do. First is const is bool, namespace is bool. So this one is more or less what you expected. Data string field, oops, gives a result. So return is bool data field. If this is the case, we return pass data field. Okay, if that's the case, then we're good. Otherwise, we can return field bool expected. So that's this, and now we have the other thing, which is called is booleanish. The function is booleanish, expects also array data string field, which gives us a result, and then we have a fallback error, which is field bool expected. Okay, and this is an OR. So OR, first possibility, that's just a bool. Second possibility is we OR something again, and if nothing works, we get the fallback error. Okay, here as well we have the fallback error, and then we OR together a non-empty string data field. Okay, this non-empty string we bind on a function that gives a value, and string to lower of that value is equals to true. If that's the case, we have a pass and it's true, and if it's not the case, then we have an error with the fallback error, right? Otherwise, we have a non-empty string data. Let's copy this, and string to lower is false, then we have a pass with false. Okay, so is booleanish is implemented. Let's check this real quick. Bool true. Okay, var dump is bool data bool. So That's true. Okay, so let's try false. That's also good. Let's try null. So that's not okay. Let's try string true. That's not working. That's because we use is booleanish, and then it's true. Or I can say write it here like in a crazy way. Okay? But if it's missing, so that's it. Functional validation on PHP. No libraries at all, everything pure functions. I hope you like it. I hope you learned something. And if not, I'm sorry. I'm also just trying to learn programming. I'm new to this stuff as well. See ya.